Hello everybody, welcome back. We are going to talk about example 12 here. It says it's talking about not a rigid motion transformation, and they're asking you for an example of that. And an example of that is a dilation. And a dilation is basically when we're talking about ordered pairs, if the ordered pairs were x and y, dilation happens when we would multiply x by a number and y by a number. And when we do if they are the same, it's still a dilation. If they're different, x and y, it's still a dilation. The issue is that we are changing the size of the shape by multiplying, and that's what makes it a not a rigid motion transformation because it's changing size. So a dilation is also known if the x and y, the multiplier on the x and y are the same values, then the dilation would be considered a similar that the shapes would be similar but not congruent. In the next one, they want us to describe the single transformation in the picture below and state the coordinate notation for the rule of your transformation. So basically, I'm going to pick a point like B here and B prime, and just kind of use those guys as my guide. And so point B is 0, 2, and has been transformed to B prime, which is now 2, 0. And so basically what's happening is if this is x and y, they have been changed places to y comma x. And this transformation, when we switch the x and y places, is a reflection across the y equals x line. So this is a reflection across y equals x. This line right here, that's the purple line that is drawn there, and that is the reflection across when the ordered pairs switch places. And if you take any of the other ordered pairs, if I took A over here, A being the point of -1 and 5, then a prime should be, if it's a reflection across the line y equals x, then it should be switching places. It should be 5 and -1. And if you look, if I go out 5 and down -1, there's a prime. So that is the reflection across the y equals x line. And so then for number 14 here, they gave us this that is a rigid motion transformation. And basically when you hear the words rigid motion transformation, what you need to understand is that means the shapes are congruent. And when they are congruent, then everything about them will be exactly the same. So it doesn't matter where the shape ends up, it's just everything's gonna be the same. So angle E is 14, F is 86, G is 104, and H is 156. It says what will H prime be? And how did I find my answer? Well, H prime, the angle measure of H prime, will be the exact same thing as H, because this is a rigid motion transformation, and rigid motion means congruent is my reason why. All right, and so then for number 15 here, we have some rules that they would like us to talk about. And so if I'm going to rotate something counterclockwise by 90 degrees, then the rule becomes -y and x. It flip-flops the y places and changes the sign on the old y. If I'm going to translate something left 8, so that is a -8, so that would be x minus 8, and then and down 2 in y, so it would be y minus 2 would be my transformation for that one. When we reflect across the x-axis, we're reflecting it from the top to the bottom, or the bottom to the top, and so the only thing that is going to change in this transformation in my rules, the x will remain the same, but the y will change signs. And last, when we have a reflection across the y-axis, well, similar that happened, we're going from right to left or left to right, and so that would mean that the x will change directions and the y remains the same. Okay, as we move along here, we're going to move down to problem number 16. And it says, if a triangle is translated, so the ideal situation is to plot this, so -2 and 0, there's T. And then 0, 5, 1, 2, 3, 4, 5. Up here is E, and B would be 1, 2, 4 over 1 up. So there's B. Here's my triangle that we are looking at. And so with this triangle being drawn, they're asking us some questions about it, and it says, if this triangle was translated 3 units to the right and down 5, what would the coordinates of the image of T be? Well, so that means that if I had an X and a Y, they want me to translate it 3 units right, so I'm adding 3 to the X, and down 5 for Y, so I'm going to subtract 5 from my Y. Well, they're asking about point T. Now, I could just do that and count. The other option is point T is -2 and 0. So if I was to substitute those in, it would be -2 plus 3 would be my new X value, and 0 minus 5. And so T prime, the translated T, is combining these guys together, which can be +1 and -5. So if I'm going to move something, I'm going to take T and move it 3 units to the right. 1, 2, 3. There's X is 1. And then down 5. 1, 2, 3, 4, 5. This guy would be T prime, which is the ordered pair that I calculated over there. All right, the next one, if the triangle is reflected across the y-axis, what is the coordinates of B? So remember, if we're reflecting across the y-axis, we talked about that up here. Then if we had the ordered pair xy, if I'm reflecting across the y-axis, the rule says -xy. So that means that I'm basically switching the X value but leaving the Y value the same. And if you look at it, all I'm going to have to do is, if I figured out how far away from the Y axis I was, if I went the other direction, that would give me the same information. So you can either do this as using the rules, or you can just kind of logically think things through. Well, if I use point B, the ordered pairs of point B, because that's what they're looking for. So B has the ordered pairs of 4, 1. And so if I use this transformation, then that means that it's going to be -4 and 1 would be my B prime. And you can look at that, like I said, we're 4 units from the y-axis. If I go 4 units in the opposite direction, that would be like right here. There would be B prime, and so you can see that it would be -4 up 1 would be my B prime, and that's really what we're looking for. All right. Down below here, we start talking about, it says, is triangle BLO similar to TRAP? And if they are, why or why not? So we've got these two triangles here, and we're trying to decide if they are similar. And so since I'm only given sides, then I don't know anything about the angles, so I'm going to think about this in terms of side, side, side similarity. Which basically means if it's side, side, side similarity, then the ratios of the sides need to be congruent to one another. So I'm going to line up the sides by the triangles up here. So BL, side BL, divided by the side TR. And so I just took the first 2 letters and the first 2 letters, divided those. If those guys divide and give me the same ratio as taking the last 2 letters, LO and RP, and that if I take those 2 sides and divide them and get the same fraction or same decimal as these guys over here, then those 2 sides would be similar. And then the last ones we got to check all the sides for side, side, side. This is a pair of sides, this is a pair of sides, and the third pair of sides would be BO divided by TP. And so if all 3 sides have the same ratio, then these triangles are similar by side, side, side similarity. So let's check it out then. So BL is 54, and I'm going to divide that by 40.5. And if that is the same as LO, which would be 30 divided by, PR, 22.5. And if BO, the 28, is divided by TP, which is 21, if all of these guys come out to be the same ratio as I divide them, same fraction, then I will end up with these guys being similar. So I'm going to go through and divide these on a calculator. I divided this one on a calculator, and I got 1.3 repeating. I divided 30 by 22.5 and got 1.3 repeating. And last but not least, 28 divided by 21 is also 1.3 repeating. So all of these ratios are the same. So these two triangles are similar by side-side-side similarity. All right, the next one, the last one on this page, is asking you the same thing. Are these triangles ACE and VNT similar? Why or why not? And says, here's the information they're giving you. So what I'm going to do is I'm just going to quickly sketch ACE. Remember that the triangles, the way they're listed up there is a specific order, so they have to match up. So VNT. And if I fill in the information, they told me that angle A was 82 and angle C was 32. And on the other one, angle V was 82 and angle T is 66. Well, basically, since only thing I have is angle information, remember our similarities, our choices of similarities are side-side-side similarity, side-angle side similarity, and angle-angle similarity. Well, of these guys, since I don't have any side information, I'm throwing that guy out. No other side information, I can't use side-angle side, so I'm going to look for angle-angle. Well, at this point, I have one pair of angles, the 82, the A and the V are congruent to each other. So far we're on the right path, but the problem is the C and N we don't know anything about, and E and T we don't know anything about. But I do know that if I add up all the angles of the triangle, 82 plus 32 plus angle E, that has to equal 180. And the same thing over here, that 82 plus angle N plus 66 has to equal 180. And if I subtract and solve for angle E gives me 66, and angle N gives me 32. So knowing this information about this, I have all three pairs of angles are congruent, but I only need two of them. So these two triangles are similar by angle-angle similarity because I only need two pairs of angles congruent and I have three. So this concludes our video for examples 11 through 9.